Bismillahirrahmanirrahim. Welcome to the course Object Oriented Programming. To take this course, you must clear the basic programming course, that is Introduction to Computer and Programming or Introduction to Computer Programming course. I am your instructor for the course. My name is Dr. Najmul Saqib. I am Assistant Professor in Department of Computer Science, ComStats, Institute of Information Technology, Islamabad campus. To start with, let's see the aim of the course. This course provides the motivation of object-oriented programming language and in-depth knowledge of various concepts of object-oriented programming and its implementation in C++. So the motivation is basically of the object-oriented programming language is basically came from the real world. We will see how this motivation arise and how this is adopted by this object-oriented programming language, and then the implementation will be done in C++. Course book. The textbook we will follow in this course is C++ How to Program by Detail and Detail, and the reference book is Weight Groups Object-Oriented Programming in C++ by Robert Leffour. So we will follow these two books, and my slides, the content of my slides, my presentation will be based on these two books basically. Let's see the course outline. We will see first what is a class, object, and member function of a class, constructor, destructor. So basically there are the main concepts of object-oriented programming is the class, object, encapsulation, polymorphism, and inheritance, and these are basically the sub-concepts that lie inside these big concepts, right? So then we will see the default constructor, returning object from a function, object and memory, static class data, constant member function and constant objects, base class and derived class. Here comes the inheritance, derived class constructor, overloading member functions, scope resolution, abstract classes, public and private inheritance, level of inheritance, multiple inheritance, aggregation and composition. And then we will see new and delete operators. So these new and delete operators are the same as we have seen the dynamic memory allocation operator in C course. In basic programming course, these are the malloc function and the free function. Then pointer to objects, virtual function, late binding, abstract classes and pure virtual function, virtual destructor, virtual base class, friend function and friend classes, static function, this pointer and dynamic memory allocation. Then we will see what is an exception handling and what is the motivation behind the exception handling. Then try and catch block, throwing an exception, catching multiple exceptions. And in the last we will see stream and files and then templates. So this is the basic course outline, and we will follow, as I told you before, that we will follow the details and Robert Leffour, these two books in this course. The marks distribution for the course is assignment is the 10% weightage of the total 100%, quizzes 15%, sessional exam 1 10%, sessional exam 2 15%, and the final exam, the terminal exam, is of 50% weightage. Let's start. Introduction. So as I told you before that there are basic or at the upper level concepts. There are basically 5 concepts in object-oriented programming language, and these concepts are object, classes, encapsulation, inheritance, and polymorphism. So in this course we will see these concepts and the further sub-concepts. Let's consider a simple analogy, a simple example. That consider that you are driving a car, and if you want to move faster, you can press accelerator pedal. That is a normal routine. And if you want to stop, you can press the brake pedal. Let's consider before driving the class, you can think of that someone designed that car and built it. So some group of people designed the car that the car should look like this, and then they, or might be other people, they built the car. Now the building, after building the car, you get the actual car. So This means that we have a kind of engineering design for the car, and then when we make a car according to that engineering design, we build a car. So the implementation of engineering design is a car, we would say. So engineering design is basically on the paper that this is the design of the car, these are the different parts, and this is the function of different parts. So there are a lot of complexity within the car. We are not going into the details. So engineering design document, engineering drawing document basically constitute all of those concepts, all of those things, or all of those functions that a car must have. So that is the engineering design of a car, right? So for example, what will happen if you want to go faster? So you press the pedal. So what things happens inside, that is told by the engineering drawing, right? And when you implement, when you make a car according to engineering design, then you get an actual car, right? So drawing also includes the design for accelerator pedal to make a car go faster. So this design basically includes lot of small design, or we can say this drawing include lot of small designs. For example, design for brake pedal, design for accelerator pedal. What will happen when a user press an accelerator pedal? What will happen when a user press a brake pedal? So this is the design that is included in the main big document, that is the engineering drawing for a car. So let me summarize that we have an engineering document or engineering design drawing for a car, and that engineering drawing contains lot of smaller design or drawing of the car, that we can say that these are the function of a car. These smaller design are the function of the car, and we group it together, the smaller function, and then it is the engineering drawing for a car. Now this engineering drawing for a car, when you implement all those things according to that drawing, you get a car, a real car, right? So we can say a pedal hides complex mechanism that makes the car go faster. So what does that hides mean? As an ordinary user, if you know how to drive a car, you know that there are 3 or let's say 2 pedals in an automatic car. The accelerator pedal, you know that there is an accelerator pedal, and if you push that pedal, the car go faster. You just know these things, but it is not mandatory for a driver to know what actually happens inside the car. So this means that this accelerator pedal hides the functionality of the car to how to go faster, how to go more faster, right? So similarly, a brake pedal hides the mechanism that slow the car. So you know that there is a pedal aside with the accelerator pedal, and using that pedal, when you press the brake pedal, it slow down the car. But the driver not necessarily actually know that how the car stops, what is the mechanism that slow the car. So I don't know this mechanism, but I don't know when I press this pedal, the car stops. This means that there is something hidden from me. Like I know if I press the pedal, the car stops, but how actually the car stops, I don't know this thing. So this means that brake pedals hides the mechanism that how the car actually stops. So steering wheel hides the mechanism that turn the car, and so on. So steering wheels, using steering wheels you can turn the car on the left side or on the right side, but you know if you turn that steering wheel on the right side, it will make the car turn right, but actually what parts are involving to make the wheel turn on the right side, you are unaware of these things, right? So this means that a steering wheel hides the mechanism that turn the car. So there are a lot of examples like this in a car. So we have seen that there is some principle that is called hide. You hide the complexity from the user and provide a simple interface to a user. So simple interface like accelerator and brake pedal, steering wheel, transmission shift. You change the gear you move up as you move faster, and etc. allow driver to interact car's complex internal mechanism. So these are the interfaces. What are the interfaces? The simple interfaces in a car is a steering wheel, is a brake pedal, is an accelerator pedal, is a shift transmission shift. So these are the simple interfaces. Using that interface, you can allow or these interfaces allow the user or the driver to interact with the complex function of the car. So the driver don't know what internally happens inside the car, but he knows that when he press the brake pedal or when he press the, let's say, accelerator pedal, the car will move faster, right? So point to be noted here are, you cannot drive the engineering design of a car. So engineering design is basically on the paper or on the laptop, inside the laptop in a soft form, right? So this is something that you cannot drive, or you can say that this is not a live entity, right? So before you can drive a car, it must be built according to the engineering design. So when a car is built according to the engineering design, then you are able to drive that car, right? So the engineering design is on the paper or inside the laptop in a soft form on a computer, but the car is actually exist somewhere, right? So the car has the actual existence, but the engineering design is something that is on the paper or on the laptop or on the computer. So the car will not accelerate on its own. A driver must press the accelerator pedal. That is very important point, that it's not possible for a car to press it by itself, its accelerator pedal, to go faster. There must be some driver, some user that is interacting with that car, and that presses that accelerator pedal or a brake pedal, or it change some transmission shift and so on. And there is another important principle, that is hiding the complexity from the user. So you can see how you can hide, how in this example the complexity of the various functions of car are hidden from the user, and a simple interface for those to run those complex functionality or to operate on those complex functionality are provided in the form of, for example, accelerator pedal, brake pedal, transmission shift, steering wheel, etc. So object-oriented programming concepts. So the function hides from user the complex task it performs. Like in our previous course, we have seen that in our, I think the first in the fourth or fifth lecture, we have seen that what is a function, and we make a bake cake function. So baking cake is maybe a complex process, and we write all those bake steps inside a block, and we call that a function, a bake cake function. So whenever you want to bake a cake, you just call that function. You do not need to know all the steps that are inside that bake cake function. You just call that function, provide the ingredients, and it will bake a cake for you, right? So we can say the function hides from the user the complex task it performs, right? So all the complex tasks are inside that function, and you just need to call that function. You just know how to call that function. What parameter should I pass to that function? This is what you should know. Like in case of accelerator pedal, for example, you should know that when I press that pedal, the car go faster, and when I release the pedal, it turns it to be into the slower speed. So same accelerator pedal hides complex mechanism of making the car go faster. So जिस तरह से फंक्शन हाइड कर रहा है यूजर से कॉम्प्लेक्स टास्क, इसी तरह से वो ब्रेक पैडल, वो जो एक्सीलेटर पैडल है, इट आल्सो हाइड्स फ्रॉम द यूजर द कॉम्प्लेक्स मैकेनिज्म दैट इज इनसाइड द कार दैट मेक्स द कार गोज फास्टर व्हेन यू प्रेस दैट पैडल. But the only thing is, in the case of function, you should know what type of value, how many arguments you have to pass when you call that function, and what is the return value. In case of accelerator pedal, you should know that how to operate that pedal. When you press that pedal, car goes faster. اور جب آپ اس پیڈل کو ریلیز کریں گے تو کار کی اسپیڈ گریجولی کم ہونا شروع ہو جائے گی. So C++ makes a program unit called class that houses various functions. So same as car engineering design houses the mechanism of accelerator pedal. So car engineering design کو دیکھتے ہیں. So car engineering design میں we have accelerator pedal mechanism, we have the brake pedal mechanism, we have the transmission shift mechanism, we have a steering, a wheel steering mechanism if you turn it right or left, and there are a lot of other mechanisms, and all these mechanisms are housed inside, lie inside the engineering design document of that car, that is on the paper or maybe on the computer. So C++ make a program unit called a class. So there is a class inside a C++ program that houses various functions. So this means that we can have one or more than one functions within a class that shows the capabilities of that class, right? We will see the detail of these things in the next few slides. So in C++, a class can have various functions that are designed to perform a class task. So the functions are there that shows, that exhibits the task a class should perform. The car engineering design document or engineering drawing for a car has lot of small functions, or we can say a lot of small mechanisms that shows the task a car can perform, or capabilities of a car. So in C++, a class can have various functions that are designed to perform a class task. For example, a class representing bank account might contain function. So there is a class that represents a bank account, let's say. So that class might contain the following function. These functions are deposit money. Through that function you can deposit money in your account, withdraw money. Through that function you can withdraw money. And current balance. With that function you are able to know what is the current balance of the bank account. Let's see the car example once again. So in real world, so engineering drawing cannot be derived. A car is built from that drawing can be derived, right? So you can build a car from that drawing and you can drive that car. Now in C++ programming, an object of a class must be created to get a program to perform the task the class describe. So you create an object of the class. So you have the drawing, engineering drawing, and you create a car from that engineering drawing, right? So you can say that car that we have created with that engineering drawing is an object of car engineering drawing, right? So an object of a class, because a class is a group of functions that shows what task a class perform. But actually if you see in detail, then in programming language, an object of a class must be created to get a program to perform the task the class describe. In order to show that what kind of task the class should perform in the program, you have to create an object of that class. Now in real world, pressing accelerator pedal sends a message to a car to perform a task. What task? Go faster. So this is kind of a message sending to a class. You are sending some message to a class. You are providing some kind of message to a class using the accelerator pedal interface, that when you press that pedal the car go faster. In C++ programming, message can be sent to object by calling a member function. So you call the function. So basically what is happening here in the real world, if you see this example, what is happening here? So pressing accelerator pedal send a message to a car to perform a task. So आप किस कार का accelerator pedal press करेंगे? किसी गाड़ी का करेंगे ना? There exists a car, there must be some car that exists, and you press the pedal of that car and that car go faster. So this means that if I say a car is an object, So my car is an object. If I press the pedal of my car, it goes faster. So in C++ programming, the message can be sent to an object by calling a member function. So if you are pressing a pedal, this means that you are basically calling a function. What function? Accelerator pedal function. And as a result of that, what you are providing and as an input information to a function, you are basically pressing that pedal or releasing it. If you press that pedal, the car goes faster. If you release that pedal, car will slow down. So the message in C++, message can be sent to an object by calling a member function. So you have a class, you create an object of that class, then you can send the message to an object by calling the member function, by calling the function that are described inside a class, right? Now we can see a car example or a car analogy is used to introduce class, objects, member function. So in case of a car class, in case of a car, what are the member function of a car? Member function are pressing accelerator pedal, the brake pedal, steering wheel, transmission shift. These are the member functions of a car. So we can say these are the capabilities of the car. So a car is capable of doing these things. So in addition to the capabilities of a car, it has many attributes, or we can say many fields, many properties. So these attributes are color, number of doors, amount of gas in tank, total miles driven, and etc. So there are a lot of attributes you can count down on your finger for any car, right? So attributes are the part of the car engineering drawing. So these attributes are basically used in the car engineering drawing to perform the various capabilities. So these attributes are always associated with a car, or we can say that every car maintains its own attribute. So my car has its own attribute and your car has its own attribute. For example, each car knows how much gas in its own tank but don't know how much is in the tank of the other car. So if I switch on my car, it shows me how much petrol I have in my tank of my car, but it won't tell me how much petrol is present in your car. So this means that the attributes belongs to that particular car. So every attribute that is explained in the engineering drawing of a car is associated with to a particular car, right? Similarly, another example could be a bank account object has a balance attribute, and each bank account object knows the balance in its account, not the others. For example, the color attribute. The color of my car is black. Maybe the color of your car is white. So the attributes are different and they belongs to the particular car by itself, right? I hope with this example, with the car example, many things will be clear to you. What is a class, what is an object. So the engineering design, engineering drawing for a car on the paper or on the computer is basically the class. So every car that you can see on the road is basically the object of that class. My car is an object of that class. कौन सी class? कार इंजीनियरिंग ड्राइंग. कार इंजीनियरिंग ड्राइंग डिस्क्राइब करती है कि गाड़ी में क्या क्या चीज़ें होनी चाहिए, क्या क्या चीज़ें होंगी, कैसे वो काम करेंगी, राइट? उनका मैकेनिज्म कैसा होगा, कैसे वो फंक्शनैलिटी परफॉर्म करेंगी. So these document, we can say this document is called a class. So that is on the paper. That means it doesn't exist. It has no existence. So if you implement that document, implement means that you make a car according to that document, then you have an actual car. This means that you can touch that car, you can perform, or you can check the capabilities of the car, and that car has its own attribute, own set of attributes. it has its own color, it can check the fuel in its tank, it has its own current speed, for example, and so on. Now, objects. So you can look around now and you will find many examples of real world objects, right? For example, your dog, your desk, your television, your bicycle, these are all the objects. Real world objects share two characteristics. They all have states and behavior. So every object that exists in the real world, now everything in your room you can find that is an object. For example, this mouse is an object. The keyboard here, this keyboard is also an object. We will see it is an object of which class, but this is an object, right? The chair on which I am sitting right now, it's also an object, right? The table on which this keyboard and this mouse, this table is also an object, right? So everything that is tangible or that has some existence is basically an object. And every object in the real world has two characteristics, and these characteristics are they have the state and they have the behavior. Now let's look at what is a state or behavior. Object example, a dog X has state. A dog X is a particular dog, let's say my dog or the dog at my neighbor. It has some state. For example, it has a color, name, breed, or hungry, and so on. And it has a behavior. Behavior are the barking, fetching, wagging tail. Your bicycle also have states. For example, current gear, current pedal cadence, current speed, and behavior changing gear, changing pedal cadence, and applying brakes. So this is a behavior or a characteristic of a bicycle. And a bicycle have a state کہ ابھی کون سے کرنٹ گیئر پہ آپ چلا رہے ہیں بائیسیکل کو, پیڈل کی جو موومنٹ ہے اس کی سپیڈ کیا ہے, بائیسیکل کی کرنٹ سپیڈ کیا ہے. These are the state of the bicycle, for example, right? For each object that you see, you ask yourself two questions. What possible state can this object be in? کون کون سی possible state ہو سکتی ہیں کسی بھی object کی, and what possible behavior can this object perform? So what I can suggest you that you can look around and note down the object and try to answer these two questions for at least 5 different objects, right? And these are the questions are: what possible state can this object, the object you find in your surrounding, can this what are the possible state of that object, and what are the possible behavior of that object? Real world objects. Real world objects vary in complexity. Your desk lamp may have 2 possible state, on and off, and 2 possible behavior, turning on and turning off. Now there is a very important point to be noted here, that is, you can always change the state of real world object through that object's behavior. So whenever you want to change the state of that object, you have to play with the behavior of that object, right? You execute a particular behavior and then the state of the object is changed, right? For example, take the example of this desktop lamp. It has 2 possible state, either on or off, and 2 possible behavior, turn on or turn off. For example, the lamp, I have a lamp and its state is off, and I want to change its state from off to on. What I have to do is I have to execute its behavior. What behavior? Turn on. So I execute that behavior and the state of the object is changed. So this is true for every real world object, that it is not possible for any object that a user or a human can change the state of that object without executing a behavior. So you have to execute the behavior to change the state of that object, and that is quite logical, right? The other example could be your desktop radio might have additional state. For example, on, off, current volume, current station, and behavior, turn on, turn off, increase volume, decrease volume, seek, scan and tune. For example, right now the state of your radio is the current station, that is the state of the radio is, let's say, 100 FM. And if you want to change that current station from 100 to 102, what you have to do is you have to execute the behavior, that is change station, right? Maybe that is not mentioned over here. You can seek it or you can scan it, maybe, right? So for example, another example could be you want to change the current volume. For example, the current volume is, let's say, 15, and you want to change the current volume from 15 to, let's say, 20. What you have to do is you have to execute the increase volume behavior. So when you execute this behavior, how you execute this behavior? There must be some kind of interface present on the radio to change or to increase that volume, right? So you execute this behavior of the desktop radio through some kind of a simple interface provided by that radio, and then the state of that radio will be changed, right? So let me repeat it. For every real world objects, you can change the state of that object by executing the respective behavior of that object. For example, in case of desktop radio, if you want to decrease the current volume, for example, the current volume is 10 and you want to decrease it to 7, you have to execute the behavior of that radio. For example, there is an interface provided by the radio, by the desktop radio object, and that interface is some kind of dial through which you can increase or decrease the volume, right? So you can turn that dial to decrease the volume, and so this means that you are executing the behavior of decreasing the volume, and as a result the state of that radio, which is current volume, is changed from 10 to 7, let's say, right? So you may also notice that some objects in turn will also contains other objects. So these real world observation all translate into the world of object oriented programming. So from here the motivation of object oriented programming came, that we can basically represent the real world object using some programming language, and that is the object oriented programming language. Let's see that in detail what is a class. So in real world you will often find many individual objects, all of the same kind. For example, there may be thousands of bicycles in existence, all of same make and model. There could be hundreds of cars that exist, and all of them have the same model and same make, right? Each bicycle was built from the same engineering design, or each car was built from the same engineering design and contain the same components. Then in object oriented term, we say that your bicycle is an instance of a class of object known as bicycle, or your car is an instance or an object of the class of objects known as cars, right? So there is a class car that basically tells the engineering drawing of how to building a car, right? And that is on the paper or on the computer. And when you build a car, like my car is built using that engineering design, so my car is an object of car class. Your car is also an object of car class. Now let's see what is a software object. Now how we can formulate that real world object into a software objects basically. So software objects are conceptually similar to the real world objects. They too consist of states and related behavior. An object stores its states in fields. So the state of object, So object have state and behavior, and software object, the states are represented by the field that is variable in some programming language. Like in C language you have a variables, so you represent fields by using variables, and exposes its behavior through methods, that is functions in some programming language, and in C language it's also a function. So a software object is basically composed of fields or variable and functions. So variables basically represents the state or attribute of that object, and the function represents the behavior or capabilities of that object. So the methods operate on object's internal state and serve as the primary mechanism for object to object communication. So let's consider this figure on the slide. So you can see in the outer circle there are 1, 2, 3, 4, 5 methods, that is behavior, and then these are the states. Now if you want to interact with the state, you have to execute a particular behavior, right? There is no possibility that you can directly interact with the field or the state of the object, right? So in order to interact with the field or state of that object, of this object, you have to execute the particular function or the behavior of that object. Now object versus classes. A class is a blueprint of an object which is a non-living entity, non-live entity. So we can say the class is on the paper basically, so that is something that is not living, we can say. An object is an instance of class which is a living entity. When you create an object basically in computer programming language, when you create an object, then the memory will be allocated. We have said that the attributes or the field of the class is represented by the variables. So those variables won't get a memory if you don't create an object of that class. So when you create an object of that class, it has some existence, so it is on the RAM, so that's why we can say that this is a living entity. Example, employee is a class, fruit is a class, and I am the object of employee class. I am an employee, so I am an object of employee class, and the apple on my table, that is an object of a fruit class, right? So regarding the living and non-living entity, let me repeat that concept once again. So class is basically the engineering drawing of the object, right? So this means that a class, that engineering drawing, is basically on the paper or on the computer, that has no existence. In a programming language, when you talk about the object-oriented programming language, when you define a class, we will see how we can define a class. So when we define a class and compile that program and run it, no memory will be allocated to that class until you create an object of that class. So the object is the instance of the class, which is a living entity. Why I said here the living entity? Because when you create an object, a memory portion will be allocated for that object that contains the list of its attributes and other necessary things, right? So when the memory is allocated for the object, it contains the list of the variables that is defined inside the class, and that basically represents the attribute or the field of the class, right? So each object has its own attribute. Like we have seen that only my car knows how much there is a fuel in its tank, but it won't know how much is the fuel in the tank of the other car. Now points to remember: a class is not a living entity, it is just an engineering design that how an object of this class look like when they are created. So objects are living entity because they had some existence inside the RAM. So that's why I'm saying that it is a living entity, because now the program can interact with that object. Like for example, you have seen, you know the definition of the structure. So this is the definition of the structure, that how you are going to create how you are going to define a structure. This type is struct book. So it create a 3 elements: character name, float, price, integer, page. So when you compile a program with just the definition of that structure, do you think that any memory will be allocated for that structure definition? So somebody can say that 10 plus 4 plus 4, 18 or 20 byte of memory will be allocated when you run that program. No, that's not true. Why? Because this is just the definition. You are defining that structure. This is same as like int is defined in C library, that whenever you are going to declare an int variable, 4 byte of memory will be allocated. It is defined somewhere in the C library. So struct book is a user defined class. So you define that definition, definition of struct book inside your program, and that is just the definition that tells when a variable of that struct book type is created. For example, like this, you create a variable b1 whose type is struct book, then b1 के लिए memory में कुछ space allocate हो जाएगी, and within that space it has a name that is 10 byte, price that is 4 byte, and pages that is also 4 byte. So this means that if we have a definition of a class and we compile the program and run it, it won't create or allocate any memory for that class, because the class is just the blueprint. It tells when the object of that class is created how that object will look like, और वो ऑब्जेक्ट किन चीज़ों से मिलके बना होगा, किन एट्रीब्यूट से मिलके बना होगा, किन वेरिएबल या किन फील्ड से मिलके बना होगा, right? So when you create an object of that class, we will see how we can create inside the, let's say, the main function or any other function. Then the memory of that object will be allocated. The type of the object is the name of the class basically, and inside that object's memory it has all the attributes or the variables that is defined in the definition of the class. Okay, let's see how we can define a class with a member function. So in this example you can see at line 8 to line 16 there is a class definition. This is called a class definition. So you have a keyword CLASS, that is a keyword written in small, and then you have a name of a class. Usually we write the first letter of the name of the class as a capital letter to increase the readability in the program, so that you can know that this capital G, this with grad book with capital G is basically the name of the class, right? And then you have the opening bracket of that class definition, and then this is the closing bracket. If you see the structure, struct is the keyword, then we have the name of the structure, and then there is the opening bracket and closing bracket. Same here, we have a class keyword, the name of the class, and then we have the opening bracket, and this is the closing bracket followed by a semicolon. Now there is a one function. We will see what is a public. Okay, so there is a one function inside the class, and this is very familiar function, void display message. So any display message, then this is the opening bracket and closing bracket of the function, and there is one statement cout less than sign welcome to grad book, less than sign and else semicolon. Since every C statement or C++ statement ends at semicolon. Now what is this cout for? This is basically same as the printf function. So cout is basically the output function, as we have seen in the previous course, that printf is basically the output function. So printf is the output function in C programming language, and cout is the basically the output function for the C++ programming language. So whatever inside this double quote will be displayed as it is. You can use inside these double quotes, you can use any of the escape sequence that we have seen in the programming course. Now then there is a keyword public. So this keyword is there. This means that this display message function is a public function. So whatever we write after that public keyword, one function, two function, three functions. So you write public, and then we have function number 1, function number 2, 3. So here in this class definition we just have one function, right? So this public keyword is basically there that tells that the display message function is a public function. Now what is a public function? A public function is a function that can be called or that can be accessed using an object of that class outside that class definition. So इस class definition से बाहर, let's say main function के अंदर, you can call display message function using some object of gradbook class, right? So the public means that you can access the public function that are defined inside the definition. So this is the definition, inside the definition of the class gradbook, and the public function that are defined inside the definition of the gradbook class, and these public function are accessible outside using the object of that class, right? So now you can see that here you can create an object within the main function. You write gradbook space my gradbook. Now my gradbook is basically an object of a gradbook class. So this is the same as you have created a variable b1 whose type is struct book. Now when you create this variable whose type is struct book, now the memory will be allocated for b1. So when you create the variable my gradbook whose type is gradbook class, so there is no need to specify the keyword class with gradbook. You can just simply write the name of the class, that is gradbook. So gradbook my gradbook space my gradbook semicolon. So this creates a gradbook object named my gradbook, and as I told you before that all the public function of the class that are defined inside the definition of the class, these public functions are accessible outside the class through the object of that class. So through the object means that now you are calling display message function with the object my gradbook using a dot operator. So with object you can write object dot, same in the case you are accessing the field of the structure. For example, in the previous example, if you want to access pages, you can write b1 here, b1 dot pages is equal to 165 semicolon. So 165 value will be assigned to the pages field of the b1 object, right? So now this means if you write my gradbook dot display message, this means that you are calling the display message function of an object whose name is my gradbook, right? So my gradbook is an object. You can have multiple objects and you can call display message with all of those objects. My gradbook 1, my gradbook 2, my gradbook 3, and now then my gradbook 1 dot display message, my gradbook 2 dot display message, my gradbook 3 dot display message. Every time you get the same thing, that is welcome to the gradbook. Now we have seen here the class definition, access specifier public. So we have seen the class definition. Why we have access specifier public? We have another access specifier that is private and another one that is protected. We will see what is the difference between these access specifier, but right now what access specifier we have studied is the public, and the public access specifier means that all those functions that are declared public inside the class definition, these functions are accessible outside the class using the object of the class. And this is what we have seen in the previous slide. Let me show you again that you are accessing this display message function using the object my gradbook. So let's say if we have another object my gradbook and then we have comma another object my gradbook 1. So you can call display message function with any of these objects, right? And then we have seen that the class body is enclosed in a pair of a curly bracket, that is opening and closing, same as the function opening and closing bracket, and the class definition, but the class definition ends at semicolon. So the member functions, there are some member functions in the class, and what are those member functions? If you try to relate that example with the car example, so the pedal, accelerator pedal, brake pedal, transmission shift, wheel steering, so these are basically the member function of a car engineering drawing class, car engineering drawing, right? So in the previous example, the member function is the display message, so that is the member function of the gradebook class. Now member function, and then we have seen a class object, what are the objects of the class, and dot operator. So dot operator is used with the object to access the public member function of that class. Let me repeat it. The dot operator is used with the object of that class to access the public member function of that class. So everything that is public, that is accessible using the object of that class. That means that everything that is public, that is accessible outside the class but using the object. Now why we have to use the object here? Is it not possible that we can call the display message function without an object? Can you think of this question, that why it is not possible to call the display message function without this object my gradebook? That is not possible. If you do so, it will give an error. But why it is not possible to call the member function of the class without the object? This is a function. We know how to call the function in the previous course, so why not we can just simply call that function? Well, this is not possible because, for example, if I am saying that I execute the accelerator pedal function in a car, then there must be some object कि मैंने किस कार का accelerator pedal press करने का function execute किया है. There must be some car, right? So if you call the function display message, then that function is executed, but you have to specify that this function is executed for object 1, 2, 3. You have to specify with the object, right? So you are saying, if you are taking the example of the lamp, you are saying, okay, I am executing the behavior of the lamp, that is turning on, so that its state is changed from off to on, but there is no lamp. Is it possible for you to execute that behavior? No, that is not possible. Then if there is no object, then it is not possible for you to execute the behavior of that object, right? Same concept applies over here. If you haven't created any object, or even if you have created an object, you have to have that object with dot operator to call a particular member function of that class, right? So अगर मैंने ये object यहाँ पे बनाया है gradebook का my gradebook ऑब्जेक्ट बना है, सो अब माई ग्रेडबुक का साथ मैं डिस्प्ले मैसेज का फंक्शन कॉल कर सकता हूँ विदाउट दैट ऑब्जेक्ट, विदाउट राइटिंग दिस माई ग्रेडबुक डॉट. अगर इसको मैं यहाँ से ख़त्म कर दूँ, माई ग्रेडबुक डॉट, you can see the mouse on the slide. If I want to omit this half line, if I erase this half line and just call the display message function, the function, it will give me an error. Why? Because it's not possible to call a function if there is no object, right? So you have created an object in the previous line, but you have to tell that you are calling the display message function of which object. You have to specify this thing. So if there is no lamp on the table, and I'm saying that I try to execute the behavior, I want to execute the behavior of that lamp, let's say turning on, to change its state from off to on, but there is no lamp here. So it's not possible for me to execute that behavior, because for that I need an actual lamp, right? So in order to execute the public member function of a class, you have to specify the object of that class. So these functions are executed basically with the object, right? So without the object, it doesn't make sense that display message function is executed with which object, right? Same as we have that if I'm saying that I'm executing the turning off behavior of the lamp, but there is no lamp actually here, right? Yes, if I bring the lamp and place it over here, then it is possible for me to execute that behavior, turning on the lamp, and it will change the state of the lamp from off to on. And dot operator is basically used to access the public member function of that class by using an object. So dot operator के left तरफ आपके पास object का name होगा, और dot operator के right side पे you have the name of the member function of that class. Let me summarize our today's lecture. In today's lecture we have seen real world analogy, various analogies to clear our concept of classes and objects and member function, and we have seen the motivation of object oriented programming language. And the motivation is that we want to represent the real world object using a programming language, and for that we have created an object oriented programming language. We have seen the objects in a real world, and we have seen that each real world object has a state, a set of state, and a behavior. And we can formulate that real world object into a software or a programming objects. And if we do so, we represent the state by a variable, and we represent the behavior of that object using a function in a programming language, right? And then we have seen another important concept, that is hiding the complexity and providing the simple interface to the user to execute these complex mechanisms. Then we have seen that it is not possible to change the state of the object without executing its particular behavior. So in order to change the state of any object, you have to execute its particular behavior. And we have also seen thoroughly that in order to execute the behavior of the object must exist, and you have to execute the behavior. If we see it using the programming perspective, we can say that we have to use an object in order to execute its particular behavior. Real world में हमारे पास lamp है. If we want to execute its behavior turning on, then I have to apply turning on behavior on some kind of lamp. So the lamp must be there then. So इसी तरह से if we want to execute any member or a public member function of a class, then we have to execute it with the object using a dot operator. Dear students, this is the end of our lecture number 1. I hope you have understand all the concepts. If not, you can just go through the lecture again, once again, read the book by Detail and by Robert Lefort. And we just start with the class chapter. We ignore the concepts of the basic programming from these books. So Detail, C++, how to program C++ by Detail, and C++ object oriented programming language by Robert Lefort. Allah Hafiz.